Hello everyone. Brew yourself a cup of coffee, settle in, and let your imagination roam free. Together, let's journey to a future that is no longer confined to the realm of science fiction. We are about to delve into one of humanity's greatest ambitions, transforming a dead planet into a second home. This is the story of Mars atmospheric engineering, a subject that scientists around the world are now investigating with remarkable seriousness. For centuries, Mars has captured our collective curiosity. The red planet, arid and barren, has long been a symbol of mystery and possibility. But as we turn our gaze from its dusty surface to the stars above, we find ourselves asking, could Mars ever become a world teeming with rivers, green landscapes, and blue skies? The dream of terraforming Mars, altering its environment to support life, remains a tantalizing vision. Yet, recent scientific analyses offer a sobering reality check. Mars simply doesn't have enough carbon dioxide or nitrogen to create a breathable atmosphere. Even more daunting, it lacks a protective magnetic field, exposing its surface to relentless solar and cosmic radiation. Any effort to reshape Mars on a planetary scale would require unimaginable amounts of energy and could take centuries, if not millennia, to accomplish with current technology. But does this mean we should abandon the dream? Not necessarily. Scientists have begun to chart a more practical path forward, known as para-terraforming. Instead of transforming the entire planet, the idea is to construct sealed habitats, whether beneath domes or underground, that shield humans from low-pressure, extreme cold, and hazardous radiation. Within these settlements, advanced technologies would convert Martian carbon dioxide into usable oxygen, harness nuclear energy, and build miniature, self-sustaining ecosystems. In these artificial oases, life could not only survive, but thrive. What's truly profound is that the research driving Mars habitation isn't just about conquering another world. The breakthroughs, drought-resistant plants, efficient soil processes, and ecosystem modeling are already finding applications here on Earth. In many ways, Mars is a living laboratory, helping us understand how to protect our own precious oasis Earth. But what is terraforming really? The term comes from Latin roots, terra meaning earth, and formare meaning to shape or form. It describes a planetary engineering process aimed at altering a celestial body so that it can support life, ideally creating a self-sustaining biosphere with breathable air and liquid water. The concept was first coined in 1942 by science fiction writer Jack Williamson. Nearly 2 decades later, astronomer Carl Sagan brought it into the scientific mainstream with a scholarly proposal on how one might transform Venus and Mars. Why is Mars the leading candidate? Among all the planets in our solar system, Mars most closely resembles Earth. In its ancient past, Mars boasted a thicker atmosphere and abundant water, conditions far more habitable than today. Venus, by contrast, is a world of extremes. Its atmospheric pressure is more than 90 times Earth's, and its surface temperatures can melt lead. Though Venus shares similar gravity with Earth, it lacks both water and a magnetic field to retain light gases like hydrogen, making it a far less attractive target for terraforming. Yet, the challenges facing Mars are immense. Its atmosphere is incredibly thin, less than 1% the density of Earth's. The average surface pressure hovers around just 6 millibar, primarily composed of carbon dioxide, over 95%, with only trace amounts of oxygen and nitrogen. Under these conditions, liquid water cannot remain stable, and the mean temperature is a frigid minus 73 degrees Celsius. To survive, humans need at least 60 millibar of pressure just to prevent bodily fluids from boiling. A threshold Mars is nowhere near reaching. An even greater obstacle is Mars's lack of a global magnetic field. Without this invisible shield, Mars is vulnerable to the solar wind, which has stripped away much of its atmosphere over billions of years. Any artificial atmosphere we create would be similarly eroded, and the surface would remain exposed to lethal cosmic radiation, posing serious health risks for any would-be settlers. So, how might we overcome these challenges? Bold solutions have been proposed. The primary objective is to warm the planet by releasing frozen carbon dioxide from the polar ice caps and the Martian regolith. Some ideas are imaginative, even controversial. One involves placing gigantic orbital mirrors to focus sunlight onto the ice caps, releasing trapped gases. Another, famously suggested by Elon Musk, involves detonating nuclear devices at the poles to instantly vaporize the ice and unleash vast quantities of carbon dioxide and water vapor. Other approaches rely on advanced technology and biology. High-powered lasers could be used to heat the Martian surface, freeing oxygen bound in mineral oxides. Synthetic biology might engineer hardy microorganisms, algae and plants capable of photosynthesizing in the harsh Martian environment. Over centuries, these organisms could gradually convert carbon dioxide into oxygen, slowly shifting the planet's climate. But even these methods face daunting timelines, hundreds to thousands of years, and may never achieve the critical mass needed for a breathable atmosphere. Recent studies, including those funded by NASA, reveal even deeper problems. The total amount of carbon dioxide on Mars falls far short of what's needed. Even if every molecule of CO2 were released, atmospheric pressure would only rise to about 20 millibar, still well below the 60 millibar needed for human survival. Nitrogen, another crucial component of a breathable atmosphere, is also scarce. Some experts joke that importing enough nitrogen from Jupiter's atmosphere would require technologies bordering on science fiction. Beyond the scientific and technical hurdles, terraforming raises profound ethical and legal questions. Introducing earthly microbes to Mars could disrupt native ecosystems, if any exist, posing serious biosecurity threats. Do we have the moral right to alter another world? The Outer Space Treaty of 1967 prohibits nations from claiming sovereignty over celestial bodies. But with private companies like SpaceX openly planning self-sustaining Martian cities, our legal frameworks are being tested in unprecedented ways. So, where does this leave us? The dream of fully terraforming Mars remains distant. Yet, it is not a futile aspiration. It drives us to innovate, to explore, and to confront fundamental questions about our place in the universe. Perhaps we will never turn Mars into a perfect twin of Earth, but we may yet create pockets of life, places where humans can live, grow, and learn amidst the challenges of a new world. Mars beckons not just as a frontier for colonization, but as a crucible for scientific discovery and human resilience. As we strive to make Mars habitable, we gain new insights into how to preserve and cherish our own planet, ensuring that the oasis we call Earth continues to flourish for generations to come.